week 10 problem solving session of the NPTEL course network analysis. And week 10 is about two-port networks. Let me share my screen. Can you see my screen?
Yes, sir.
So we are in the week 10 now. Last week we have discussed about the process of how to use the graph theory in the network analysis, and we have solved a few problems. And later we have discussed on about the dependent source, dependent voltage source, dependent current source, and how to apply Thevenin's theorem when there is a dependent source. This week we'll be discussing about two-port networks, and we'll first discuss about various parameters of two-port network, like Y parameters, Z parameters, T parameters, and H parameters, and then we'll discuss about relation between them, and then we'll move on to reciprocity and symmetricity of a two-port network. What are the conditions that needs to be satisfied for a given two-port network to be symmetric and reciprocal? Then we'll solve few problems. Okay, so the today's topic is two-port network. Sorry. So two-port network means it has two ports, uh, a port one, port two, and any port could be input, any port could be output. So let us consider a two-port. So here it has one input, and here it has another port. Anything could be input, anything could be output. Both can be input, both can be output. So kindly note the convention. Here we are taking this is V1 and this is V2, and the convention that we are considering or that we will be considering throughout this session as well as this course, whatever conventions are has considered is like we are considering plus minus. This is plus, this is minus, and both are supplying the current to the two-port network. So this is our two-port network. So this is our two-port network. So kindly make sure you remember this convention, because whatever parameters that will be deriving, everything is dependent on the current direction as well as voltage polarity. So I'll write note so that you'll remember. Kindly note the current direction and voltage polarity. Okay, so this is very crucial. So kindly keep this in mind. And this is the convention that SAR is using. We can use any convention, but whatever convention that we start with, we should stick to it, and we should do the same thing, else one minus sign will be added. So we have to be careful with that. So first we'll start with short circuit admittance parameters, or also called as Y parameters. So we have first parameter, which is the short circuit. You are following, right? I'm audible, right?
Yes, sir.
Okay. Admittance parameters, which are also called as Y parameters. So admittance is nothing but current by voltage or voltage by current.
Current by voltage.
Current by voltage. So current is equals to voltage into admittance. So in this part, we will do nothing but we'll on the LHS side we have currents, on the RHS side we have voltages. So how many currents are there here? I1, I2. So two currents are there and two voltages are there. So if we write I1, I2, on the LHS side into the admittance matrix multiplied by the voltage V1, V2. So here we will be getting the admittance matrix. It will be 2 cross 2, Y11, Y12, Y21 and Y22. So if you multiply them, you will be getting two equations like I1 is equals to Y11 V1 plus Y12 V2 and I2 is equals to Y21 V1 plus Y22 into V2. So if we want Y11, then what we need to do from this equation, we have to make sure V2 is 0, which means we will short this and then we'll calculate I1 V1. So my I1 by V1 is Y11. Similarly, if I want Y12, I will make V1 0, which means I'll short this and then I'll give V2 here and then I'll calculate I1 and I'll check I1 by V2, which will be my Y12. So similarly, we can calculate all these parameters, but there are specific names to these parameters which are crucial. So I'll list down the names. So one is the driving point admittance. So another thing. So let us name this. So this is say port 1 and this is port 2. So the driving point admittance of port 1 is Y11 matrix and the driving point admittance of port 2 is Y22 matrix and Y12, Y21 are transfer admittance. Sorry, the driving point admittance of port 1 is Y11 parameter and the driving point admittance of port 2 is Y22 parameter and these two are the transfer admittance. So the driving port admittance of port 1. Driving port admittance of port 1 also Y11 is nothing but our I1 by V1 when V2 is 0. Do you agree? So from this equation, I'll make sure V2 is 0, which is nothing but I'll short this and I'll give only V1. So now I can calculate V1, I1 and I2. So I1 by V1 will give me Y11. Is this clear until this point? How we are getting this?
Yes, yes.
Okay. Now similarly, so this is the driving point admittance of port 1. So now if I say calculate Y12, which is also called as transfer admittance, then we'll get transfer admittance, which is Y12. Now here we have to make V1 0 and calculate the ratio between I1 and V2 when V1 is equals to 0. So we are getting from basically from this equation. So whichever parameter we want, that will keep and the other term will make it 0. Either it could be voltage or it could be current and accordingly we'll find these terms. So now similarly, we can get the driving port admittance of the other parts like port 2. So I'll just copy paste this terms here and I'll change. So now we'll be getting port 2 and this one will be different. And here also transfer admittance. So now we'll get driving port admittance of driving, sorry, this is driving point, not port. Sorry for that. So this is driving point admittance because it is being driven by the voltage source. So that's why it is named like that. Driving point admittance of port 2, which is Y22. So Y22 is I2 by V2. So Y22 is nothing but I2 by V2 when V1 is equals to 0. Similarly, transfer admittance, Y21 is also called as transfer admittance. Y21 is equals to, if I want to get Y21, it is I2 by V1. I2 by V1 when V2 is equals to 0. So this is the driving point admittance of port 1, transfer admittance, driving point admittance of port 2, and transfer admittance. And this is how these Y parameters are defined. So when we say Y parameters, it is the relationship between currents and voltages. So currents of port 1, port 2 with the voltages of port 1, port 2. Because these are said admittance because currents are expressed as a function of voltage. If it had been the other way, like if the voltages are expressed as a function of currents, then they are called impedance parameters or Z parameters. So for admittance, we need currents and we are making voltage 0, right? V1, V2, 0. Whereas if we write voltage in terms of currents, then we have to make currents as 0 so that we'll get the parameters. So if we have to make the voltage 0, we'll do short circuit. If we want to make the current 0, then we have to do the open circuit. So let me just quickly take, say if we want to calculate y21, how we'll be doing. So for calculating y21, so this is our two port network, right? So this is our two port network. So we want I2 by V1. So V2 is 0. First of all, V2 is 0. So V2, I'll just short circuit. So my V2 is 0. Then I'll excite it with V1. So this is my plus minus V1 and this is my I1 and make sure current direction. So now from this I'll get my Y21 as my Y21 as I2. I have to calculate I2 and then I have to calculate V1 and I have given V2 to be 0. So this is how I individually calculate. In the case of admittance, we are making the voltage as 0. For that, we are short circuiting it. So that's why it is called short circuit admittance parameters. Whereas if we do it the other way, if we write the voltages in terms of currents, then you have to make the currents as 0, which means it's an open circuit. So they are called open circuit impedance parameters or Z parameters. So until this point, it is clear, or if you have any doubts, you may ask.
Clear, sir.
So we'll quickly go through the open circuit impedance parameters. Z parameters because it is impedance. They're called Z parameters. So let us just copy this two port network there so we can use this two port network throughout our session. So here what we will be doing, here we'll write voltages in terms of currents because it is impedance. So here on the LHS we have V1, V2 expressed as a function of currents I1, I2. Now the matrix will be Z, Z11, Z12, Z21 and Z22. So this is our Z matrix or the impedance matrix. Now again, if I write the equations individually, I will get V1 is equals to Z11 I1 plus Z12 I2. And similarly, my V2 is Z21 I1 plus Z22 I2. So similarly, if I want Z11, I have to make sure I2 is 0 and then I'll divide V1 by I1. So quickly, let us define these parameters. So these are called driving point impedance. Instead of admittance, it will be impedance because it is. So if I have to write, it will be impedance. Sorry. This is impedance. Driving point impedance. So of port 1. Now it will be again Z11. This one also. So we have Z11 is equals to V1 by I1 when I2 is 0. Similarly, transfer impedance, right? Transfer impedance. We'll have Z12, which is V1 by I2 when I1 is equals to 0. Are you following? Is this correct, or have I made any mistake? Hello? Hello? Hello, am I audible? Hello? Kumar Reddy or Sudhir, am I audible?
Yeah, yeah,
Okay.
yeah.
Okay.
Audible.
Okay. Okay. So now we'll define the other.
Yes, sir, audible, sir.
Okay. 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 So we'll define the other two parameters also, which are Z12 and Z21. So this is port 2. We'll have Z22 and the other one. So we have Z22, which is V2 by I2 when I1 is 0. So V2 by I2 when I1 is 0, and Z21 is V2 by I1. V2 by I1 when I2 is 0. So again, we'll consider this example, how to calculate Z21. So let me just quickly take this example. So now what do we have here? We have one circuit and we want I2 to be 0. So as this is open circuit, instead of making short circuit, we have to make it open circuit. So we'll make this side open circuit. And we have here I2 0 and this voltage is plus minus V2. Again, make sure we are following the same polarity because I have selected positive at the top in the beginning and we are following the same convention throughout. And I2 is how much? I2 is 0. Here we have I2 is equals to 0. So now if I calculate Z21, it will be V2 by I1 and I2 is 0. So instead of connecting a voltage source of V1, we can also connect a current source of I1. We have studied this theorem, right? So a voltage source can be converted into a current source or uh, voltage source. So this we have studied, like impedance also we can transform this into. So basically it is having current input current I1. So as this is V1, so we are connecting like this, or for better understanding, you can directly connect a current source of I1, which is supplying I1, and then having a voltage polarity across it as V1. So either way, it is the same thing. It's just a voltage source, current source written in different way, but both will be giving the same answer. So this is how we'll calculate the impedance parameters. So have you understood, or is there any confusion until this point?
Okay, sir. Okay.
Clear, sir.
Okay. Okay. So now these are the Y parameters, which are admittance parameters, and the Z parameters. Now we'll go to H parameters, which are called hybrid parameters or H parameters. Hybrid parameters or H parameters. So here the relationship is between V1 and I2. So, okay, let me first copy the diagram. So previously it is voltages and currents. Now it is input voltage and output current. So we have on the LHS side V1 and I2. Is equals to I1 V2. So the first one is input voltage, like port 1 voltage, port 2 current, port 1 current, port 2 voltage. And the parameters are H parameters. So H11, H12, H21, H22. So these are defined like this. So now if I ask you how to calculate H11, can anyone say how to calculate H11? Say I'm calculating H11. How to calculate H11? What needs to be made zero and a fraction of what and what gives me H11? Anyone? Like which current or voltage needs to be made zero and fraction of what voltage or current to what voltage or current?
V2 must be made 0
Okay.
and it will be V1 by I1.
Yes, you are right. So it will be H11 is equals to V1 by I1 and V2 is 0. Others agree?
Yes, sir. Yes, sir.
And H12?
Yes, sir.
I1 should be
H12
made
is equal
0.
to V1 by V2,
V2.
sir.
Okay.
Yet I1 is equal to 0.
Okay. So others, do you agree?
Yes, correct.
Yes. Similarly, if I do H21, it will be I2 by I1
I1,
at
V2 is equal to 0.
okay. And H22,
H22, I2 by I1,
I2,
I2 by V2
okay.
at I1 is equal to 0, sir.
Yes, you are right. So this is the parameters we are getting. So now let me quickly go back here. So here, what is the like dimension or the unit of Y?
Admittance, sir.
Admittance. So inverse of ohms, right?
Mm.
Yes, sir.
Yes. Or more, they say. Here, what is the unit?
Impedance, sir.
Impedance.
Ohms.
Ohms, omega. So here, if I ask the impedance, the dimension of this, what is the dimension?
Ohms, sir.
Ohms. Or I would say impedance, as you are saying, impedance. So it is
Yes, sir.
omega.
Mm.
And for this one,
No unit, sir.
dimensionless. Yes.
Dimensionless.
For the other one,
No unit, sir.
H21 is also dimensionless.
dimensionless. And the last one,
Admittance, sir.
H22
Ohms.
admittance. So this has to be clear because it is hybrid and it's not just voltages and currents. So some have impedance dimension, some have the admittance dimension, and some are dimensionless. And this is just simple. So here we are just representing the voltage currents in a different way. And our LHS are different, RHS are different, but the way how we calculate V1, I1, I mean H11, H12 is simple. If V2 is 0, we'll short this. If I1 is 0, we'll open this. If V2 is 0, we'll short this. If I1 is 0, we'll open this. And accordingly, we will calculate the corresponding currents as well as voltages, and we'll take the fraction of that to get whatever we want. So yeah, so this is about hybrid parameters. Do you have any queries or any questions?
No, sir.
Okay. If you have any questions, you may ask at any time. Even if you have questions in the previous one, you can ask at any time. Don't think that as we have moved on to something new, you cannot ask. You can ask at any time. So now we'll do something called or discuss about transmission line parameters or T parameters or ABCD parameters. So these are transmission line parameters or ABCD parameters. Okay. So as these are transmission line parameters, they are also called as T parameters. And they are denoted by ABCD. So basically here it is mainly used in transmission line where they'll find the relation between input and output. So V1 I1 and V2 I2. So that's why they are called transmission line parameters. And as I said, so here the relation between the input and output. So uh, we'll have V1 I1 on one side and V2 I2 on other side. So when they consider transmission line, they'll consider V1 I1 as source. So V1 I1 as source and V2 I2 as sink, or it is like a load. So source will supply power and load will consume the power. So here it is supplying, this is supplying and this is consuming. Okay. So this is the voltage and current directions of what? Source or sink? V1 I1. Is it supplying power or is it consuming power?
Supplying.
Supplying. And this one?
Port 2 is receiving, that is sink.
But according to our voltage and current, is it supplying power or is it taking power?
According to the I2 should be coming out.
Yes, yes. So yeah, that is the thing. So here we'll keep the I2 will be I2 only, but instead of considering that direction, we'll consider in the other direction with minus I2. So now as if it is taking the drawing the current, but we have just put a negative sign for our convention. So it is basically the relation between V1 I1 and V2 minus I2. So as if this is our source and this is our sink. So this is just same to same as this one. Here it looks as if it is supplying the power, but here we have just considered the opposite direction with a negative magnitude. So still both are same, but here it is consuming the power. So it is acting like a load. So this is the convention for T parameters. So this is very much useful in transmission line. So this will also be useful when multiple such two-port networks are cascaded. Then how to get the relation between the input and the final load. So this part specifically we'll discuss in the next week. But keep in mind, so it is the relation between the input as well as output, where input is acting like source and output is acting like a sink. So here we'll have V1 I1 in the LHS side and V2 and minus I2 on the RHS side. V1 I1. And on the RHS side, we have V2 and I'm highlighting this is minus I2. So we have ABCD parameters A, B, C, D. So can you tell me what is A, what is B, what is C, what is D?
A V1 by V2, sir. A is equal to.
Okay. Let me write. A is V1 by V2 when
When I2 is equal to 0, sir.
I2 equals to 0. Similarly, B is
V1 by minus I2 at V2 is equal to 0.
yes. C
I1 by V2 at I2 is equal to 0, sir.
1 by V2 at I2 is equals to 0. And D finally.
I1 by minus I2,
Okay.
I1 by minus I2 at V2 is equal to 0.
Okay. Now, can you quickly tell me what is the dimension of each and every term?
No dimension, sir.
Okay. So this will be dimensionless.
Impedance,
Dimensionless impedance.
impedance, admittance, no
Ad-
dimension.
Okay. Yeah. Good.
Yes.
So others, do you agree?
Yes, yes, correct.
Yes. Okay. So like this is just a basic introduction about different parameters. We have discussed about admittance parameters or Y parameters, followed by Z parameters, then followed by H parameters, then followed by T parameters. So let us just quickly get relationship between multiple parameters. So all these parameters are in terms of V1, V2, I1, I2. So any parameter can be expressed as a function of other parameters. So this relationship can be formed. So first we'll start with one easy example, which is the relationship between Y parameters and Z parameters. So I will not discuss relationship between each and every possibility. We'll just discuss how to get that relationship, how to get relationship between say Z and T, Y and T. One example we'll take, and then we'll have to understand the flow so that if asked in the exam, we can get a relationship between any other parameters. But how we are doing that process is crucial. So now we have a relationship between or relation between Y and Z parameters. So let me take the two matrices. So here we have Y and here we'll copy it. So we have I I1 and this one is our Z parameters. So how to get the relation between these two? Do you see anything between LHS, RHS here and here?
Sir,
Reciprocal.
inverse, sir.
Yes, yes, you are right. So basically it is just an inverse. Say this, I call it one Y capital matrix. This I'll call capital Z matrix. Then I can say that Z is equal to Y inverse. Right. So I'll have Z11, Z12. So if I take, we'll have Z11, Z12, Z21, Z22 is equal to Y11, Y12, Y21, Y22 inverse. So we just have to do the inversion of this and then compare the matrices terms, individual terms. So if we do that, we'll get Z11 as first we'll have in the denominator delta, right? And what we'll be having in the numerator? So what is inverse of this y11, y12, y21, y22? So it can be written as, say the determinant is delta. It is 1 by delta into y22, y11 minus y12 minus y21, where delta is nothing but y11, y22 minus y12, y21. So this is the thing, the relation between like inverse matrix of a 2 cross 2 matrix. Now from here we'll get Z11 is nothing but y22 by y11, y22 minus y12, y21. Similarly, we'll get Z12 is minus y12 by y11, y22 minus y12, y21. Similarly, I can get z21 as y21 by with a negative sign y11, y22 minus y12, y21. Now, if I do the same for z22, I'll be getting negative sign y11 by y11, y22. Sorry, there is no negative sign here. Minus y12, y21. So did you get this? How we are getting the relation between y and z parameters?
Yes,
Yes,
sir.
sir.
Yes.
So there is less than a minute and this meeting will end and you join back to the same link so we can continue our discussion. So this is quite simple and straightforward, the relation between y and z parameters. Both matrices are just inverse of each other. So we'll do the inverse and we'll get. Whereas if we go in some other example, like I have considered here h and y parameters. So if you see h, the LHS, RHS are completely different. And in such case, how to get the relation. So that we'll discuss quickly before we move on to the symmetricity and reciprocity. And this meeting will end. If it ends, kindly join back. So we have now relation between h and y parameters. So relation between h as well as y parameters. So first what we'll do is we'll just copy paste our h parameters as well as y parameters. So first I'm copying h parameters. Okay. So let us copy h parameters. Okay. Now we'll copy y parameters. So what is y? Admittance. So we'll go to our first thing and we'll copy this and we'll get here. So if you see in one case, we have to get V1, I2 in terms of I1, V2. And in the other case, we have to get I1, I2 in terms of V1, V2. So I just have to play with these two equations so that instead of writing V1 in terms of I1, V2, I have to write I1 in terms of V1, V2 and similarly I2 in terms of V1 and V2. So first we are taking this and we are getting this. So first we'll consider this. So what are the two equations that are there here? So first equation is V1 is equals to H11 I1 plus H12 V2. So the idea is or the objective is to write I1 in terms of V1 and V2. So this is our candidate. So I have to keep this in the LHS and RHS should be V1 and V2. So now what can be done? I can write this as I1 is equal to minus 1 by or plus 1 by H11. So this thing into V1 minus H12 by H11 into V2. Or am I making any mistake? Just kindly check the calculation if I'm missing any plus or minus sign. So basically, I have taken H11 I1 on the LHS side and then divided by H11. So it will be 1 by H11 V1 minus H12 by H11 into V2. Is that clear? Or did I make any mistake?
Okay, okay.
Okay. Then the second equation. So basically from this, we are getting these two equation. So first equation is this. The second equation is I2 is equal to H21 I1 plus H22 V2. Now I got the first equation. So here I got the first equation. Now I need to get the second equation. Second equation, I need to isolate I2. So I2 is already on the LHS side. But what do I need in the RHS side? I need V1 and I need V2. So V2 is already there. So this I1 I have to replace in terms of V1 as well as V2. So what I'll do, I'll use this I'll use this I1 and then I'll substitute it here and then I'll simplify the equation. So now I can get I2 is equal to, so if I multiply that, what is the V1 coefficient? H21 by H11 into V1 plus H22 minus H21 H12 by H11 into V2. Just check if my calculation is correct. So basically I have substituted I1. So we'll get H21 by H11 into V1 and then minus H21 H12 by H11 plus H22. So I have written like this. Is this clear?
Yeah, okay, fine.
Okay. So now if you see, this is my Y11, this is my Y12, this is my Y21, and this is my Y22. So I got Y in terms of H. So if I write, I got Y11 is equal to 1 by H11 and Y12 is equals to minus H12 by H11 and Y21 is equal to H21 by H11 and Y22 is equal to H22 minus H12 H21 by H11. So here we got relation between y and h parameters. The similar thing could be done for any two parameters. So now if I ask what is the relation between t parameters and say z parameters. So now you have to get the two equations, just do some mathematical manipulation and yeah, the objective is like what will be on LHS, what will be on RHS. Accordingly, we have to play with these two equations, substitute one variable in the other equation and get in the format. So here we have two equations. We are just manipulating them basically and getting in the way we want. And then we'll be getting relation between this. So similarly, you can try for others, but this is the basic idea how to do for any two given parameters, how to find the relation. So is this clear? First, we have discussed y and z, which is very straightforward. And then we have discussed two h and y, where they are not straightforward, but we just have to do some manipulation to get the relation. So is this clear how we are doing this?
Yes, sir.
Okay. So now we'll discuss something called reciprocity or what when a two port network are said to be reciprocal. What is the like condition that it has to follow so that we can say that it is called reciprocal. So reciprocal two port network. Okay. So first I'll give the definition, then I'll explain. So a network is said to be reciprocal if the ratio of the response ratio of the response current in the short circuited port, the response current in the short circuited port to the excitation voltage in the other port. Even if the excitation or this should remain same, sorry. So this remains same even if the excitation and even if the excitation and the response even if, sorry. So even if the excitation and response are interchanged among the or between the two ports, between the ports. So this is the definition, but let me just explain before we go into the details. So we'll consider one two port. Where is our two port? We can consider this small example. So basically, there is one excitation port and there is one response port. So say first we are considering port 1 as excitation. So it is saying the network is said to be reciprocal if the ratio of the response current in the short circuited port. So one port is short circuited. So first one port is short circuited. Say this port is short circuited. Now the ratio of the current in the short circuited port. So this is the current to the excitation volt in the other port. So port 1 is here excitation and port 2 is the response. So the response in one port, which is again short circuited port. So this is also short circuited port. The ratio of I2 with respect to the excitation voltage V1 should remain same even if we interchange. So basically what they are saying is if I, sorry, so if I interchange this one, so this is our circuit. Now I'll just interchange. Interchange in the sense voltage I'll be giving there, current I'll be taking here. So let me erase this and erase this. So here excitation voltage is here. So our excitation voltage is here, which is again plus minus V2, and this is our short circuited port. So one port is the excitation port where we are giving voltage. The other port is where it is short circuited and it is the response port. So the ratio of the response to the excitation should remain same even if we interchange the excitation as well as the response between the ports. So in these two cases, I have interchanged the excitation. Here I am giving at port 2, here I am giving at port 1. But it is said to be reciprocal if the ratio to the response, ratio of the response to the excitation remains same. So basically what their intention is, the response I2 to the excitation when the port 2 is short circuited should be same even if it's the other way. So here I1 is the response, V2 is the excitation, provided V1 is equal to 0. Did you understand the terminology what it is saying? So the definition
Yes,
is okay. So the definition is if two ports are if a two-port network is reciprocal, then one condition should satisfy. The condition is there will be one port with excitation voltage, the other port, the response port, short circuited. So the ratio of the response to the excitation should remain change even if you interchange the excitation and response. So for this two-port network here, this is the excitation, this is the response. Here it is the excitation, this is the response. So the ratio of the response to excitation should remain same in both the cases. Then it is called reciprocal. Okay. So now we can get relation in terms of y parameters. We can get relation in terms of z parameters. We can get relation in terms of t parameters, other parameters. First, we'll start with the y parameters. Okay. So let me quickly go here. So let me copy this. So can you tell me I2 by V1 when V2 is 0? What is that? I2 by V1 when V2 is 0.
Y21,
and I1 by V2 when V1 is 0.
Y12,
Y12, yeah, correct.
both should be equal.
They should be equal. Yes, yes, you're right. So Y12 should be equal to Y21. And this is the condition for the two-port network to be reciprocal. So if my Y parameters, the diagonal terms are equal, then it means it is reciprocal. I mean, these two, not this diagonal, these two. Then it is called, then it is reciprocal. Because here it is simple. I2 by V1 when V2 is 0, I1 by V2 when V1 is 0. Now it is very straightforward. But whereas in the case of, say, Z parameters, now can you say directly what will be the condition? I2 by V1 when V2 is 0 or I1 by V2 when V1 is 0? It is not straightforward, right? Hello. Hello.
Yes, sir.
Yes. So here it is not so straightforward. We'll not get directly. So in that case, what we'll do is we'll just do like consider these individual equations and then accordingly we'll manipulate. So let me just say. So there are two conditions that we need to get. One condition V2 is 0, I2 by V1. Other condition V1 is 0, I1 by V2. So I'll just put this here. So these are the condition, right? So these are these equations, right? Individual equations. Do you agree?
Yes, yes.
Okay. So now first I need to get I2 by V1 when V2 is 0. So first my condition I'll consider is V2 is 0. Then I'll get I2 by V1. So if V2 is 0, then what will be the equation? V1 is equal to Z11 I1 plus Z12 I2. And V2 is, sorry, V2 is 0, right? So V2 is 0. So in the second equation, we'll get 0 is equal to Z21 I1 plus Z22 I2. So I need I2 by V1. So I need to eliminate I1. So first I will be getting I1 from here. I1 is what? Minus Z22 by Z21 into I2. Agree?
Yes, sir. Yes, sir.
Yes. So now I'll substitute this I1 here. Then I'll get V1 in terms of I2. So let me write. So my V1 equal to Z11 or Z12 minus Z11 into Z22 by Z21 into I2. Agree?
Yes, sir. Yes, sir.
So now I'll get I2 by V1 when V2 equal to 0 is nothing but Z21 by Z12 Z21 minus Z11 Z22. Agree?
Yeah, yeah, correct.
Hmm. So this is when V2 is 0. So I got my LHS. So this part I got. Now I need to calculate RHS. RHS is when V1 is equal to 0. So now instead of V2 equal to 0, we'll consider V1 equal to 0. And we'll consider two equation and then we'll see whatever equation that we need that we are getting or not. So 0 equal to Z11 I1. So we'll have 0 equal to Z11 I1 plus Z12 I2. and the other part is same. V2 equal to Z21 I1 plus Z22 I2. So now we want what? We want I1 by V2. So V1 should be, sorry, V1, not V1, I2 should be eliminated. So I2 I'll write in terms of I1. So my I2 is minus Z11 by Z12 into I1. Agree?
Yes, sir. Yes, sir.
So now I'll substitute this in I2. Then I'll get something like this. V2 equal to Z21 minus Z22 into Z11 by Z12 into I1. Isn't it? Do you agree?
Yes, sir.
Okay. So now if I calculate whatever we want, I want V2 by, sorry, I1 by V2, right? I want I1 by V2 when V1 equal to 0. So now my equation is Z12 by Z12, Z21 minus Z11, Z12, right? Agree?
Yeah, correct.
Yes. So now if this one and this one is equal, if you see the denominator,
Sir, that is, sir, denominator
uh-huh.
Z12, Z21 minus Z11, Z22, sir,
Oh, sorry,
Z12,
sorry,
sir, that
sorry,
is.
sorry. Yeah, you are right, you are right. Yeah. So thanks for correcting. So this is Z22, right? Now is this okay?
Yes, sir. Yes.
So now if you notice here and here, the denominator are same. So the numerator should be equal, right? This one and this one. Agree? If this is equal to this one, because that is our condition, right? For reciprocal, this should be equal to this, right? Or let me just drag it here. So Control C, Control V. So if both are equal, what is the condition?
Numerator should be equal.
Equal Z12 equal to Z21, right? So we'll get Z12 equal to Z21.
Z2.
So this is for Z parameters. Similar way we can do for T parameters, we can do for H parameters, but I'll not do because we will not be getting that much time. But the process is simple. This is the LHS I want, this is the RHS I want. So first I'll make V2 0, I'll get I2 by V1, but just by substituting the other parameter, I'll get one ratio. Here, similarly, here we'll get another ratio, and then we'll equate, then we'll get the this final expression. So this is Z21. Okay. So similarly, if you do for H parameters as well as T parameters, then whatever condition that you will be getting, I'm just writing it down, but I'll not be discussing it today because we are running out of time because there is problem solving session also that needs to be covered. So, but the process is same. You try to do it during your free time. If you face any questions, then you can ask me. I'll be helping. So, if we do the same, then we'll get a network is said to be reciprocal. Like what are the condition that we'll be getting? I'll write. A network is said to be reciprocal if, so there are four equations, right? One, two, 3, 4. First, y parameters, we got y12 is equal to y21. Y12 is equal to y21. Similarly, we got z12 is equals to z21. If you do for h parameters, you will get h12 is equals to minus H21. So H12 is equals to minus H21. Or one thing I can say, I got what did we get? Y12 equal to Y21, right? This condition, isn't it? Y12 equal to Y21.
Yes, sir. Yes, sir.
Okay. So now I'll do this Y12 equal to Y21. So what is the condition in terms of H? These two. Y12 equal to
Yes,
Y21
sir. Yes, sir. Minus.
minus H21, right? So that is what we'll be getting, H12 equal to minus H21. Similarly,
Okay.
if you do for T parameters, you will get AD minus BC equal to 1. So a network is said to be reciprocal if these things are like same. So this is all about reciprocal. So if a network is said to be reciprocal, then these are the condition that it needs to satisfy. So now we'll go to our final topic of today, which is symmetric two-port network. So what is symmetric? Symmetric two-port network. So what is the definition? A definition is a network is said to be symmetric if the currents and voltages remain same even if you interchange the currents and voltages of port 1 and port 2. So if I keep V1 at port 1 and V2 at port 2, or if I connect V1 at port 2 and V2 at port 1, it will current should remain the same. So it is symmetric. It doesn't matter. Even if I look from port 1 or look from port 2, it is just the symmetric circuit. So like it is symmetric if the voltages and currents remains unchanged, even if the input and output sources are interchanged. So first, I'll write the definition, then we'll write the condition. A two-port network is said to be symmetric if the voltages and currents remains unchanged, even if the input and output ports are interchanged, even if the input and output ports are interchanged. Okay, so which means no matter you look from port 1, so if you look at port 1 or look at port 2, the circuit is looking like the same, which means if I look from port 1, or if I say the impedance through port 1 should be same as the impedance through port 2, which means V1 by I1 when I2 equals to 0, or V2 by I2 when I1 equals to 0. So those are the impedances, right? So if I go back here, the impedance parameters. So V1 by, so the impedance looked into this port, which is V1 by I1 when I2 equal to 0, or Z22, which is the impedance through this port, the driving point impedance of port 2, V2 by I2 when I1 equals to 0. So these two needs to be equal. So let me just take this. So the driving point impedance should be same. So instead of short circuit here, we have voltage, open circuit, and I2 equal to 0, I1 is equal to 0. So basically, whatever we are getting here, we got a condition, right? Similarly, we have to get a condition. That condition is like the impedance should remain same. So we have V1 by I1 when I2 equals to 0 should be same as V2 by I2 when I1 equal to 0. Then the two-port network is said to be symmetric. Okay. So we'll go V1 by I1, V2 by I2. So let me go back here. So what is V1 by I1 when I2 is 0?
Z11,
And V2 by I2 when I1 is 0?
Z22.
Z22, right? So Z11 and Z12 it should be equal. Now I'll come here. Z11 and Z22 are equal. What is the condition between Y11 and Y22?
Again, Y11 should be equal to Y22.
Y22. Yes. So again I'll come back here. Y11 equal to Y22. What is the condition between H?
H11, H22 minus H12, H21
H21
should be equals to
equal
1.
to 1. Yes, you are right. So basically it is pretty straightforward. So let us consider this Z parameters. So I'll just quickly write here. So we have over here, if we consider Z parameters, then the condition that we will be getting is Z11 equal to Z22. Okay. So this is one condition that we got. Now I'll go here and I'll consider these things. So one is this one. Okay. We'll do individually. So if we do this, we have Z11 here and then I'll get Z22 also. Where is my Z22? This is my Z22. So from this we'll get Y11 equal to Y22, right? We'll get Y11 is equals to Y22. Now I'll take Y11, Y22 and get the relation between H11, H in terms of H parameters. Okay, and then I'll delete this and I'll bring it here. Okay. So from this you will get H11, H22 minus H12, H21 equal to 1. I'll not consider ABCD that you can do by yourself. If you face any difficulty, you can ask me at any time. But I'll just summarize.
A equals to D.
A equals to D. Yes, you will be getting something like A equal to D, but that needs to be done because if you see ABCD, where are ABCD? So here we'll get A is in terms of V1 by V2. So it is not straightforward. Again, you have to consider these conditions individually. Like one case I2 is 0, in another case I1 equal to 0, and get the this type of thing, then you will get. But I'll just summarize the parameters something like this. So a network is said to be symmetric. A network is said to be symmetric. So again, in terms of y1 and y parameters, z parameters, h parameters, t parameters. So we got y11 equal to y22, z11 equals to z22, and h11, h22 minus h12, h21 equal to 1, and then we'll get a equal to d. This part I have not discussed today, but just assume that it will come something like that. So this is our like theory. So do you have any doubts? If you have any doubts, you can ask before going to problem solving session. Else I'll just summarize what we have discussed and then we'll move on to problem solving session. Any queries until this point?
No, sir.
Okay. So I'll just quickly summarize what we have discussed today. So today, the discussion is about two-port network. So we have discussed the voltage and polarity as well as current direction in a two-port network, which we'll be considering throughout our course as well as our session today. So first we have discussed about four parameters of a two-port network: Y parameter, Z parameter, H parameter, T parameter. Y parameters are the short circuit admittance parameters, which can be written something like this, and we have discussed them individually, what are their names and how to get the parameters for a given two-port network. Similarly, for Z parameters, which are also called as open circuit impedance parameters, we have considered what are the parameters individual equation and what are their names and how to get these parameters individually for a given two-port network. Followed by H parameters. H parameters are a bit tricky. So input voltage, output current, output voltage. Accordingly, we have defined them and we got the individual expression, and we have seen some of them are having dimension of impedance admittance and some of them are dimensionless. Then we discussed about the T parameters. Again, there is one catch here in T parameter. One is source, one is sink. So I2 current should be in the opposite way. But according to our convention, I2 is flowing towards left with the magnitude I2, which is also equivalent to current flowing towards right with the magnitude of minus I2. So we have considered this. Now the relation is between V1 I1 and V2 minus I2. So we'll be getting something like this where ABCD are defined like this. And here also some of them are dimensionless, some of them are having dimension of impedance as well as admittance. Then we moved on to the relationship between two parameters. So we just have to play with the two equations to write in a different way. So here we have currents as a function of voltages. Here we have voltages as a function of currents. So if we do direct inversion, then we'll be getting the relation between parameters. Whereas in the case of other parameters like say H and Y, the LHS, RHS are not same for these two. So in that case, you have to manipulate these two equations to write currents in terms of voltages. Here, voltage and current are in terms of voltage and current. So you have to manipulate these two equations to write in this format. So then I'll get a relation between Y and H parameters. And then we have discussed about something called reciprocity, where the definition is given over here and the condition that it needs to follow is given over here. So for any Y parameters or Z parameters, we'll consider V2 equals to 0, find this ratio, V1 equals to 0, find this ratio and equate them. Then we'll get the relation between Z11, Z22 as well as H parameters and ABCD parameters, and these are the equations or the conditions that it needs to satisfy so that a network is reciprocal or not can be checked. Similarly, for symmetric, the basic idea is same. The impedance of this port and this port should be same, or the admittance of this port should be same. So the condition is when current through one port is 0, what is the ratio of voltage to current in the other port? So that is what the impedance means. So this impedance of port 1 and port 2 should be same because it is symmetric. So it does not matter from which 2 points you are checking, both are just symmetric. So for this condition to be satisfied, if you do Z parameters, Y parameter, H parameter, D parameter, you will be getting this kind of relationship, and this should hold good. Then only a network can be said to be symmetric. So if in the question they ask you Y parameters, you will get Y parameters. If they ask whether the circuit is symmetric or not, first I'll check whether Y11 is equals to Y22 or not. If it is, then the circuit is symmetric, else it is not. If I go to reciprocity, Y12 should be equal to Y21. If it is, then the circuit is symmetric, else it is not. So until this point, is this clear? So that is the like overall summary of today's discussion. Before we go into problem solving session, do you have any doubts? If you have any doubts, you can ask. Any more queries? Hello.
No, sir. No.
Oh, okay. So yeah, today we'll discuss a few problems. Again, there is less than a minute, so probably this meeting will end before we start discussing. Okay, so Yeah. Let me just quickly go to our lecture material and assignment 10. There is less than a minute and this meeting will end. Kindly quickly join back. We'll discuss a few problems. So we'll consider this problem first. Okay, so I hope this meeting will end soon. Just join back quickly. Okay, so this is our today's problem solving session. And this is our problem one. So in the question, they're asking find the H parameters of the above network. So they're asking H parameters. So before we move on to the question, I just want to go to my H parameters and then I'll see what I need to calculate first. Okay. So I'll go to H parameters. Then I'll just write it over here so that I'll know what I need to calculate. So these are my H parameters. Then I'll just see how to individually calculate the H parameters. In that case, it will be pretty clear to me. So what needs to be made 0 and what needs to be set so that I can get. Okay. So first, in any question, if they ask something, you have to first write this matrix format or this equations. So now I know in order to calculate H11, I have to make V2 0. So I'll short V2. Then when V2 is shorted, so if you see over here, this thing as well as this thing is when V2 is equals to 0. And this thing and this thing are when I1 is equals to 0. So in the first case, I will short V2, I'll get H11, H21. In the second case, I'll keep V1 open circuit, then I'll get H12, H22. Is that clear?
Yes.
Okay. So first part is V2 should be 0. Do you realize that if I short V2, then this 2 ohm is shorted?
Yes, correct.
So I'll just remove this 2 ohm because it is redundant. I'll just short this and I'll remove 2 ohm. Okay. So we'll start with our first case, which is V2 is equals to 0. Okay. So I'll keep here V1 and I1 3 ohms. So we have over here 3 ohm and we have over here V1 and here we have a current source and this is short circuited. 2 ohm I have removed because it is anyway getting shorted. So this is 0.2 V1. This is 0.2 V1. This is 3 ohms. This is V1 and this is I1. So now can you tell me what is I1? Assume this is our ground. Anyone? I1? V1 in terms of I1? Apply KVL in this loop, small loop.
Sir, V1 is equal to minus 3 I1.
Minus or plus?
Minus.
Sure.
Yes.
Okay. So this is our 0, right? So this is at high potential or low potential, plus V1 or minus V1?
Sir, at low potential.
This point, top point.
Yes.
Why? This is plus.
Sir, that is positive. Yes, sir, that is
So this
positive.
top point is at plus V1, right?
Yes, sir.
So this is at high potential, not low potential, right?
Yes, sir, that is at a high potential.
Yes, yes. So if I apply KVL, it will be V1 plus 3I1 or minus 3I1?
Sir, -3.
Minus 3I1. So
Yes,
what
sir.
is my V1 by I1?
Uh,
3,
3.
sir.
So, so V1 by I1 corresponds to what parameter? When V2 is 0?
H11, sir.
H11. Yes, you are right. Is equal to H11. Now, what is the other parameter? H21, which is I2 by I1. Right. Agree?
Yes, sir.
Yes. So what is my I2? I2 is this direction. So this is my I2, right? So I can write I1 is V1 by 3. And what is my I2? This is my I2. So what is the?
Minus 0.2 V1.
Yes, minus 0.2 V1. And what fraction I want? I want I2 by I1. So can you tell me what is I2 by I1?
Sir, minus
Sir,
0.2
minus
by
0.6.
Yes, yes, you are.
Minus 0.6.
Minus 0.6. Yeah, yeah. So this is my which parameter?
I2 by A1, sir.
So
I2
which
by
one?
A1, H21,
To
sir.
1.
H21, yes. So I got H11, H21. So this is when V2 is made 0. Now I have to make V1 to be 0. Sorry, V1, I1 to be 0. So V1 will be open. So this will be open. And here I'll give voltage source and current source. So now in the other case, I1 is equal to 0. So we'll have resistor like this. And here it is short circuited. This is open. And here we have a current source. And there is this 2 ohm resistor here. And there is this voltage supply here. So this is my plus minus V1. This is our 3 ohm. This is 0.2 V1. And this is how much? 2 ohm. And this is V2. And this is I2. Okay. So can you quickly tell me what will be this current?
Sir, 0.2 V1 plus I2
Plus I2, right?
plus I2.
Okay.
Yes,
And
sir.
can you tell this current in terms of V2? Say this I have considered to my ground. So this potential is V2, right? Agreed?
Yes, sir.
Okay. So now what is this current through 2 ohms? What is the current through 2 ohms in terms of voltage V2?
Sir,
Voltage across it is V2. Resistance is 2. What is the current?
V2 by 2, sir.
Yes, V2 by 2. So we have V2 by 2 equal to 0.2 V1 plus I2. Okay. Now, what is the two things I need to get? I need to get V1 in terms of V2, I2 in terms of V2. Okay. So how to get from this? First of all, what is V1? Any idea?
Sir, 0.
Yes. Because our I1 is 0. This is the I1 that is 0. So the potential across 3 ohm will be 0. So if this is I1, this is sorry, this is V1, this is V1. Do you agree?
Yes, sir. Yes, sir.
So our V1 is 0. So our V1 is 0. So if V1 is 0, then can you tell me what is our H11? H12?
So 0.
0. Yes. So our H12 is 0. Now substitute V1 in this above equation. So substitute it here. So can you tell the rest of the equation? What is the rest of the equation?
Sir, V2 is equal to 2I2.
2I2. So this should give me the final parameter, which is what?
0.5, sir.
Which parameter?
H22, sir.
Yes, H22. So from this, I'll get I2 by V2 equal to 2, which is my H22. Therefore,
Sir, 1/2.
oh, sorry. Yeah, 0.5. Thank you. So therefore, the H parameters can be obtained as, so this is our H11, or we'll use a different color. So our H11, H12, H21, H22. So this is our H matrix. Then what did we get? What is our H11? 3, right?
Yes, sir.
H11 is 3. So this we have 3, and H12 is 0, and H22 is 0.5. The other one is
Minus 0.
minus 0.6.
Uh,
Yes. So this
yes,
is
sir.
our H parameter, whatever they have asked for. So we'll check whether we are getting the same one or not. H11 is how much? 3, right? So it is in the range, right?
Okay, sir.
Yes. And H12 is 0. It is 0. H21 is minus 0.6 in the range. H22 is 0.5 in the range. Correct?
Done, sir.
Yes. And one thing, if you see, H11, H12, H21, H22, what are the dimensions? So that is also one important thing. So H11 has impedance, so that's why they have mentioned impedance. Whereas H12 dimensionless, H21 dimensionless, H22 is having inverse of ohms or mho, which is this unit. So that unit they have mentioned there. Is this clear?
Yes, sir. Clear.
Okay, so now we'll solve the other problem. So this problem where they have asked multiple questions, or I think this is one big question where they're asking Z parameters, Y parameters, and also this is a little bit interesting. So we can solve this question. So how to proceed with this? Any idea? Because
Star to delta, sir.
yes, you are right. So star to delta. So this problem. So which one should be changed to what?
362 ohms to 36
Yes.
ohms are in star, sir. It is
Yes.
converted into delta.
Yes, you're right. So these 362 are in star. If I make it delta, then I'll get, okay, I'll just write. So problem 2. So if I change this, then I'll get one resistor here, another resistor here, and another resistor here. Now these two 8 and that resistance will be parallel. So we'll have only 3 resistors, and we can directly apply whatever we want to apply, and we can easily get. So for this star delta, we'll quickly go back to our lecture. In which week have we discussed? I think week 7 or week 8 we have discussed. Let us check. Is it here? Yes, here. So it is in week 7. So let us open our notes. Is it open it? It is opening. So you can see the screen, right? So here we are having this star delta. Okay. So let me just copy paste it there and we can use it. So we'll keep it here and this is for our use. Okay. You are able to see my screen, right? Hello.
Yes, sir. Sir.
Okay. So now we have like this. So now let me call this with a name. Say this is my R1 and this is my R2 and this is my R3. So now we have to calculate R1, R2, R3. So R1. So first R1. So the previously it was something like this in this format. Now we are converting into delta. So we are actually moving from here to here. So if I want RA, which is opposite to R1. So if I want R1, which is opposite to 6, I'll be having in the denominator 6. Agree? Agree? Like here, if I have R1 opposite to RA, because R1 is opposite to RA, right? Because previously, maybe if I draw like this. So this is our R1, this is our R2, this is our R3. So whatever is opposite to R1, RA, that has R1 in the denominator. Agree?
Yes, sir.
Yes. So for all of them, the numerators are same. So numerators are 3 into 6 plus 6 into 2 plus 3 into 2. Can you tell me what is the numerator? 3 into 6 plus 6 into 2 plus 3 into 2.
Six, sir.
Numerator. 3 into 6 plus 6 into 2 plus 2 into 3. So it is 18 plus 12, 30, 36, right?
Sir, I think do we need to find RA, RB, RC
Yes,
or
yes.
R1 not to
RA,
R2?
RB, RC. Actually, maybe it would be good if I change the this thing, then it will be easy. Say we have RA, RB, RC, then there will not be any confusion. So we were finding RA. So what is RA? 36 by
36 by 6, sir.
36 by 6. So 36 by 6. So my RA is 6 ohm. And what will be my RB? 36 by
RB. Final answer is 12, sir.
yes, 36 by 3, right? So RB is 12. And my RC 36 by 2, right?
Yes, sir. 18, sir.
18. Now what is RC parallel 8 ohm? It is nothing but 18 into 8 by 18 plus 8. Right? RC is how much? 18 and this is 8. 18 into 8 by 18 plus 8, right? How much we'll be getting?
5.54, sir.
Okay. So 18 into 8 by 18 plus 8. 5 point, how much are you getting?
5.538.
5.54, sir.
5.54. Okay. Okay, fine. So now effectively we'll have one resistor here, and another resistor here. So let me redraw it. So we'll be having our circuit something like this. Okay. So this is our plus minus V1, I1, plus minus V2, I2. So this, how much is RA? RA is 6 ohm. So this is 6 ohm. This is 12 ohm. This is 5.54 ohm. Okay. So now we'll go back to our question and we'll see what they have asked. In the question, they are asking Z parameters as well as Y parameters. Right? Agree?
Yes, yes.
Okay. So if I get Z parameters, I'll do inverse and I'll get Y parameters. So first let us concentrate on the Z parameters. So for Z parameters, we'll quickly go to our this portion and we'll just copy paste. Okay. So this is our Z parameters. So for getting Z parameters, what I need to do is I need to open circuit either I1. I mean, I have to make either I1 0 or I have to make I2 0. Right? If I make I1, I2 0, then I'll get Z11, Z2, 2. If I make, if I make I2 0, I'll get Z11, Z21. If I make I1 0, I'll get Z12, Z22. Right?
Yes, yes.
Yes. So, first case one. I'll consider I2 to be 0. As if that side nothing is connected. So we'll have our circuit. So this is our circuit V1, I1, and this is 6 ohm. This is 12 ohm, 5.54 ohm. So effective impedance or ZR effective is nothing but 6 parallel to 17.54 ohm, right? Agreed?
Yes, sir.
Yes. And also, if I consider this is my plus minus V2. Okay. Can you tell me R effective? Anyone, could you please calculate R effective?
4.47, sir.
4.47.
47,
Okay.
sir.
4.47 ohm. So if
Yes,
R
sir.
effective is 4.47, what is V1 by I1? 4.47, right? Agree?
Yes, sir.
So what is V1 by I1 when I2 is 0?
Z11.
Z11, yes. So this is our Z1. So for calculating Z21, I need V2 in terms of I1. Okay. So for calculating V2 in terms of I1, first we'll calculate this current I dash. I dash is 6 by 6 plus 17.54 into I1. Agreed?
Yes, sir.
Yes, sir.
Also, V2 is 12 times I dash, which is 12 into 6 by 6 plus 17.54, which is my into I1. So now can you tell me V2 by I1? What is my V2 by I1? Someone just quickly calculate. Anyone? Just 12 into 6 by 6 plus 17.5.
3.05.
3.05. Okay. So this is my which parameter? V2 by I1 when I1 is 0.
Sir, 3.0.
3 point. Sir, can you please repeat?
3.06, sir.
0.6. Okay, fine. So this is which parameter? V2 by I1.
Z21.
Z21. Okay. So now I got two parameters. I need to get the other two parameters. Okay. So in the second case, I'll make I1 0. So this will be there and here only I'll give supply. So 6, 5.54 and 12. So if I redraw it again, this is my 6, this is my 12, and here is the input. So this is V2 and this is I2. This is 5.54 ohm. This is 6 ohm. This is 12 ohm. Correct? Yeah. So now my R effective and also this is my plus minus.
Yes, sir. Yes, sir.
So what is my R effective? R effective is 12 parallel 11.54. Can you tell me what is this value? It will be close to 6, not exactly. 12 into 11.54 by 23.54.
5.88.
Yes, sir. 5.88, sir.
5.88 ohm. So my V2 by I2 is 5.88. V2 by I2. So V2 by I2 is equal to 5.88. This is which parameter? V2 by I2 when I1
Z22, sir.
is Z22. So this is our Z22. Now I want Z12, which means I want V1 in terms of I2. Okay. So this is my I2. Say this is my I2 dash. So I2 dash is nothing but 12 by 12 plus 11.54 into I2. Also V1 is 6 into 12 by 12 plus 11.54 into I2. So now can you tell me what is V1 by I2? So it will be close to 3.
3.06, sir.
3.06. Okay. So we have 3.06. This is which parameter? Z12, right?
Z12, sir.
Yes. So now we got all the Z parameters. Okay. We'll write the Z parameters. Therefore, our Z11, Z12, Z21, Z22. Okay. Z11 is 4.47 and then 3.06. 4.47 and 3.06. Z12 is 3.06 and Z22 is 5.88. Okay. 5.88. Okay. Let it be. Now can you tell me the delta? Delta of this is 4.47 into 5.88 minus 3.06 whole square. Can you tell me what is the value of this?
$16.92, sir.
I'm not sure. 16.92. How much? 16.92, right? Okay. Just
Yes,
others.
sir.
Let me check. Okay. So now I can directly write y11, y12 as an inverse of this y21, y22. So we'll get 1 by delta 1 by 16.92 into 5.88 minus 3.06 minus 3.06 4.47. So basically what it is means this should be inverted and here it will be minus, here also it will be minus. So can you quickly tell me and the individual values, what are these values? Y11, y12, y21, y22. It is 5.88 by 16.92 minus 3.06 by 16.92 minus 3.06 by 16.92 4.47 by 16.
0.35, sir. First one.
Okay, 0.35.
Yes, sir. Next to minus 0.18, sir.
187. Okay. So this will also be the same.
Yes, sir. Yes, sir.
Next one,
0.26. 0.26, sir.
26. Okay, thank you. So we got y11, y12, y parameters as well as z parameters. Okay. So let us kindly go back and see whether we are getting correct or not. Z11, how much we are getting? 4.47. So it is within the range. Z12, how much we are getting? Z12 minus 3.06. So minus, no. So there is no minus. Again, it might be confusing. So I'll just remove because I myself got confused. So that minus is when we do the inverse. So actually there is no minus. So 3.06 and 3.06. So 3.06 in the range, 3.06 in the range. Z22, 5.88 in the range. Y11, 0.35 in the range. Y12 minus 0.18 minus 0.187. So they have given up to 189. So in the range. Y21 also same. So it is also in the range. Y22, 0.26 in the range. So now my question is whether this is a two-port network, reciprocal or symmetric. So let us quickly go back and see what is reciprocal, what is symmetric. So
Reciprocal.
reciprocal means y12, y21 should be equal. So this diagonal should be equal if it is reciprocal.
Sir, sir, Z12 is equal to Z21.
Z22. If this diagonal is equal, it is symmetric. So here we'll see which diagonal, which is equal, this diagonal or this diagonal. This diagonal is equal, which means Z21 equal to Z12. So whether it is reciprocal or symmetric.
Only reciprocal.
Sir, reciprocal.
Not symmetric.
Reciprocal, sir.
Yes, not symmetric, only reciprocal. So we'll go back. So it is
sir.
reciprocal, yes. Symmetric, no. Yes, so our answers are matching. Therefore, given network is reciprocal. And not symmetric. Okay. So do you have any doubts as we are uh, coming close to 8 o'clock? I will just wind this up. If you have any doubts, you may ask in this question or the previous question.
No, sir.
Okay. If you have no question, just let me summarize the problem solving session. So we have considered two problems today. In the problem one, they are asking H parameters. So first we have written how to calculate the H parameters. Then we have seen either in one case we have to make I1 equal to 0 to get these two parameters and V2 equal to 0 to get these two parameters. So first we have made V2 equal to 0, we got the two parameters, I1 equal to 0 and we got the other two parameters. So it is very simple and straightforward. You need to know which parameter need to be made 0. In the second problem, which is a little bit tricky, it's actually a complicated circuit which could be simplified by using star delta transformation. Then it will be very simple. If you have to solve this question like this and you have to calculate V2 I1, it will be very cumbersome and it will be very complicated. So here we could see that there is a star which could be converted into delta. So now instead of four resistors, we'll have only three resistors and it is just very straightforward to get all the parameters. So they have asked Y and Z parameters. We have calculated first Z parameters and then used the inversion and we got the Y parameters and they have asked whether it is reciprocal or symmetric. We have checked from our results whether it is holding good symmetric, it is not holding, and for reciprocal, yes, it is satisfying. So the given network is reciprocal and not symmetric. So as a summary of our entire session today, first we have discussed about two-port network and the four parameters that we can find for a two-port network, followed by the relation between parameters, followed by the condition for reciprocity, the definition of reciprocity, and followed by definition of symmetricity and the condition for symmetricity. Then we have considered two problems. In the first problem, we have calculated H parameters. The second problem, we have calculated Y and Z parameters. Similarly, you can calculate T parameters also. And then you can also use the relationship between multiple parameters. And you need not do multiple parameters for each and every question. If you see in this question, I have not calculated Y parameters by calculating I1 by V1, I1 by V2. I have calculated Z and I have used the inverse matrix to calculate, which have saved a lot of time and my results are also correct. So yeah, this is how you can proceed further. If you have any questions, you may ask. And yeah, if you don't have any question, then we can end this session here and I'll try to upload this video by tomorrow. Any queries?
No, sir. Thank you.
Okay. Yeah, thanks for joining.
No, sir. Thank you, sir.
Yeah, thank you. And all the best for your assignment. Do well in your assignment. Yeah, thank you for joining and
Yes,
thanks
sir.
for being active and having a nice
Thanks.
discussion. All the best and good night. Have a nice day. Thank you. See you in the next week.
Okay, sir. Good night, sir.
Good night.